This video is on DNA replication. Again, we're talking about nuclear DNA in eukaryotes. So we saw before that it's packaged in chromatin, which is a complex of DNA and proteins, and has a variety of different structures, a hierarchy of structures. One thing to mention is that inside of the cell, it's not the same kind of situation that we experience in water. Even though the cell is made of water, at that level, the Reynolds number is very low. The Reynolds number is a ratio of inertial forces to viscous forces. So inertial forces are like F equals ma. You push something, it floats away from you in space. Viscous forces being more like, I guess, just like the difference between water and like a thick oil. You can see here just an example of low viscosity versus high viscosity kind of a fluid. So as things are drifting around inside of a cell nucleus, they're kind of trudging through like a thick viscous fluid. And then the nucleotides that are the building blocks of DNA need to be in supply in order for DNA to be replicated. So there's a whole process of maintaining the right ratios of deoxynucleotide triphosphates. And also the DNA is going to be coiled. So we're talking about eukaryotes and linear chromosomes, but there should still be some twisting and tension in the double-stranded DNA. So the DNA has to kind of manage that tension and take steps ahead of time before it replicates the DNA to, well, I might be thinking more of a transcription, but still there's a twisting and tension in the DNA that kind of needs to be taken into account when replicating the DNA. And the topoisomerase is the enzyme or protein that helps relieve the tension by handling this supercoiling. So the cell cycle, like here, I think is specific to mitosis, but you have various phases, and the synthesis phase is where the DNA replication is performed. And before I mention that, the DNA replication process also has to replicate the chromatin. So there's histone proteins that are being created at the same time the DNA is being replicated. Well, I guess it's part of the growing process of the cell that needs to create more nucleotides and more histone proteins to be able to create these nucleosomes. So the existing DNA strand has nucleosomes on it. It has these beads on a string once it's kind of unpacked. And so as it duplicates the DNA, it has to remove the histones, disassemble the nucleosome, and then duplicate the DNA, then create a nucleosome on the new strand and the old strand. So this is just reiterating that. So S phase has histone synthesis and nucleosome replication needed to kind of just duplicate the entire chromatin that condenses into the chromosome during mitosis and meiosis. And the DNA replication process is covered in detail in a lot of places. You have anti-parallel strands, so you kind of have this some kind of origin of replication, and you have a protein complex going in each direction, causing the strands to be duplicated. And there's a lot of details in that process that I'm not going to cover. That might be pretty close to it. At the end of the process, they've been duplicated, and the cell separates the chromosomes, and you end up with 2 copies of the information, or in meiosis, you've made 4 copies of the original diploid information.